Alright, overview of data collection principles. Here we go, moving on to section 3 in chapter 1. So, first off, a lot of this is going to be kind of terms that we're going to be using throughout this whole semester and year that you're going to need to know what they are. So, first off is a population and a sample. So, population, what a population is it's all the targets in a given question. So, if I'm asking for, let's say, what is the average height of people at the school, the population would be every single person at the school. Okay, so every single person at the school would be considered the population. They all fit that target question. Now, if I'm asking what's the average height of every freshman at the school, that would be the population is now just all the freshmen. Okay, the sophomores, juniors, seniors don't matter. It's just the freshmen. Okay, the sample is a subset of that target question. So let's say I wanted to ask the question, what's the average height of the people at the school, the whole high school, and so the population would be everyone in the high school. The subset or the sample that I could take would be everybody that's in the statistics class. Okay, that would be my sample. It's a small subset of the overall target population. Now, the closer you can get to a good selection of it, the better it is for your sample, whatever it is that you're trying to look for. So, what is the average mercury content in swordfish in the Atlantic Ocean? So, what is the population? The population would be the swordfish, all the swordfish in the Atlantic Ocean. So, every single swordfish in the Atlantic Ocean. Now, if we want to find what the average mercury content is of these, it would be very difficult because there's no way for us to find every single swordfish in the Atlantic Ocean. Okay, so what we would do is we'd use a sample. We take a group of 60 and we measure their mercury content. Okay, that would be, this is where a sample is very nice. By using that compared to the population, you're able to take what would be thousands and millions and taking only a smaller subset. If you think about this with, let's say, the election, so if you are trying to see, okay, who are people going to vote for? Are they going to vote for candidate A or candidate B? To find what the actual answer is would be to ask every single person that's going to vote. Okay. The problem is that you can't. It takes too much time. People don't want to tell others who they're going to vote for, so you can't really do a population. So what you do is you do samples. So all these polls that you see, they're all samples. They're taking 20 people from here, 15 people from here, 17 people from here, and they're taking different groups. Okay, and so that's what's happening is they're taking samples to see if they can predict the overall population. Okay, all right. Next up, variables. So in math, you've dealt with variables of different kinds. So variable here is just the characteristic of the population that we're looking at. Okay, so whatever the characteristic is that you're looking at. So if you're talking about, let's say, the election, the variable is who are they going to vote for? Candidate A, candidate B, or candidate C, D, E, since there's more than just two people running usually. So whatever the variable is what you're trying to find that's going to differentiate everybody. The parameter is the actual number from the population. So if I were, in conclusion, at the end of, let's say we're looking at the election again, the final vote numbers would be the parameter. That's the actual number. Okay. Next up is the statistic, and the statistic is the number that you found from the sample. So all these people that are doing polls that are saying candidate A has 50%, candidate B has 47%, those are statistics. Okay, it's what they've gathered from a sample. Okay. At the end, on election night, candidate A ends up with 49%, candidate B ends up with 46%. That is the parameter. That's what the actual number was. Okay. Population and parameter go together, so the P's go together. Population, everyone, parameter, the actual number. And then your sample and statistic go together. The S's go together. Sample, the smaller group, statistic, what you got from that one. So if we are going, what's the average mercury content for swordfish in the Atlantic Ocean? The variable in this case would be the mercury content of every single swordfish. Okay, so that would be your variable. Okay, the population, again, what we've stated earlier, is all the swordfish. A sample is a subgroup of that total population. The parameter would be what? The actual average mercury content of all the swordfish. And then your statistic ends up being the average mercury content from the sample that you took. Okay, so that's what it is. So the variable is the average mercury content, population is all the swordfish, sample is the small group of swordfish that you took, parameter is the actual average mercury content, and then statistic is the average that you found from your sample. Okay, so we have two different types of two different categories of ones that we're going to be looking at. We're going to be looking at what are called mean data and proportion. So let's start off with mean. Mean is just going to be your numbers. So the average mercury content, that is a mean. Okay. When we're dealing with the parameter, which is again the actual number, we use the Greek letter mu. Okay, which is that little U with a little tail in front. It's pronounced mu. And so that is your parameter. So whenever you see that little symbol, that is mu. That means it's the actual average or actual mean. The statistics, for statistic, what we use is we use what's called an X bar. An X bar is just an X with a line over it. And that's your calculated mean from a smaller sample. A proportion, which are your percentages. So when you're dealing with proportions, you're dealing with percentages. Your parameter, so the actual proportion is going to be p, lowercase p, is denoted for your parameter. So the actual, so going back to the election, candidate A got 49% of the vote. That would be p. Okay. Your statistics, what was polled or what was calculated beforehand, is your p hat. Okay, which is p with a little v on top of it, and we say it's p hat. And so what we would say is that it's that would be from their poll. So if your poll was 50%, that would be your p hat. Okay, so the actual number was 49, that's p. The polled number was 50, that's p hat. Okay, so that's just the difference between them. So we use different things when we're talking about different things. All right, anecdotal evidence. So anecdotal evidence. Anti-smoking research started in the 30s and 40s. Cigarette smoking was growing in popularity. So around the 30s and 40s, more and more people were smoking because it was cool to smoke. Might have also had something to do with prohibition. But some smokers seem to be more sensitive to the cigarette and cigar smoking than others, and some were completely unaffected. Okay, so that's just kind of some background. So originally they faced a whole bunch of resistance from people because people would respond with the following: my uncle smokes 3 packs a day, and he is in perfectly good health. Okay, the reason why this is bad is because all the evidence that you're taking is from a very small sample size. My uncle, my father, I smoke all the time and I am not sick. Okay, just because it works for one person doesn't mean it doesn't affect everybody else. Okay, just because you can go around and you can eat a cake every single day and not gain weight doesn't mean everybody has to eat a cake every single day and they won't gain weight. Okay, just because it has effect on one person doesn't mean it is the same for everybody. Okay. And at this time, basically, it was concluded that smoking is a complex human behavior, and it's hard to study it. Basically, there's too many variables. This was back in the 30s and 40s. Okay, so at the time, they're like, well, it's one of those things, we don't know why some people are affected by it, others are not. It's just how it is. Okay, but over a longer period of time, so then when you get into the 60s and 70s and 80s and 90s, they're doing more and more research. They're getting more and more people that are smoking. They're able to see what happens to them. Okay, so they get a larger sample size. They're able to see trends. Okay, one person is not going to tell you a trend. 2 people aren't going to tell you a trend. You need dozens of people to be able to find a trend. Okay, and then after decades of them doing it, they're able to find and see that the more people smoke, they were more unhealthy. Okay, they were sicker. Um, they ended up getting lung cancer. Their life ended up being shorter. There's a whole bunch of different health things that they found are connected to smoking in some way. Okay, so just because it's evidence is what you see in a small sample size doesn't mean it's always true. So you've got to look out for that. So just because it's true in one thing doesn't mean it's always true, and that's your anecdotal evidence. Okay, explanatory and response variables. So when you're looking at a relationship between something, smoking kills. Okay, so smoking kills. The smoking is your explanatory variable. Okay, smoking explains why people die. Not everybody, some people. And then you want to see, is there a connection? Okay, so your explanatory is what is causing everything, and your response is the result. Okay, so chewing gum ruins your teeth. Are they connected? Studying hard, getting A's. Are they connected? Okay, so your explanatory is kind of what you're doing. The response is what's happening because of it. You hit your sibling, you get punished. Those are connected. Okay, so there might be an effect to it. So that's what we're doing whenever we're doing these studies, that we're trying to see, is there a connection between them? Okay. Now, sometimes when we do go, oh, is there a connection? Smoking causes cancer. You could justify taking statistics either way, saying yes or no. Okay, so just because it might look like it doesn't mean it is. And just because you say, oh, this affects that, doesn't mean it will always. Okay. Observational and experimental. So, observational studies are studies that are where you collect data just by observing it. Okay, this is usually done in the aftermath. Okay, so it's done later, and then you can find the association after. So, looking at historical data. Okay, that would be an observational study. Okay, you're looking at what's happening later. If you're not getting in, adjusting something, that is observational. If I just sit in my classroom and watch and calculate how long students work on something, that's observational. Okay. An experiment or experimental is where you randomly assign people to various treatment groups and then you try to make a connection between them. Okay. So that one is you are actually adjusting something with one group. Association and causation, they're not always connected. So what you have to do is you have to make sure you don't say that just because there's an association, it's the cause of it. Okay. There could be something else. There could be multiple things affecting it. It's not going to always be just one thing. Okay. You can't just go, oh, I see an association. That must be the cause of it. Okay. So if you see a little cartoon underneath here, read it as joking about causation and association. Alright, so your homework in this one is numbers 1-7 through 1-12. Okay, that's your homework in this section.